All right, let's talk about something we see all the time: scores. Scores on exams, personality quizzes, you name it. But have you ever really stopped and thought about what's going on inside that single number? Well, every score has a secret story, a tale of what's real and what's just random noise. And today, we're going to pull back the curtain and uncover that story. So let me ask you this. Imagine you take a big test on Monday. Then, through some magic, you get to take that exact same test again on Tuesday. No new studying, nothing's changed. Would you get the exact same score? Your gut feeling is probably no, right? But you'd expect them to be pretty darn close. And that little gap, the difference between your Monday score and your Tuesday score, that's where our story really begins. It's all about randomness. Maybe you guessed right on a tricky question the first time, but wrong the second. Or maybe you were just in a better mood taking a survey on Monday, but on Tuesday, your cat had woken you up at 3 a.m. That randomness is everywhere, and understanding it is the secret to understanding any test score. So to make sense of all this randomness, people who design tests have this, well, it's a beautifully simple but really powerful idea to guide them. It's the core of what's called classical test theory, and it all boils down to one little secret formula. And that big idea is reliability. At its heart, reliability is just about consistency. It's how much we can trust that a test is free from that random error. A reliable test, it's going to give you a consistent result, time after time. An unreliable test is one where the score is mostly just that random noise we've been talking about. To really get this, let's build out that formula. It all starts with the observed score. This is the easy part. It's the number you actually see printed on your paper, whether it's a 95% or a C-. It's the real-world result you get. Now, here's where it gets interesting. That score you see is actually made up of two hidden parts. The first one is your true score. Okay, this is a theoretical concept, so stick with me. Imagine you could take the same test an infinite number of times. Your true score would be the average of all of those scores. It's your perfect, actual skill level, totally free of any random luck or a bad day. And that brings us to the last piece of the puzzle, the error score. This is everything else. The error is basically the villain of our story. It's all the random junk that pushes your observed score away from your true score. The entire goal of making a good test is to make this error score as tiny as humanly possible. So where does this villainous error even come from? Well, it usually has two main hideouts. First, there's trait error. These are factors inside you, the test taker. Maybe you didn't sleep well, you're in a terrible mood, or, as one of my sources hilariously points out, you've just fallen in love. Then there's method error. This is all about the situation itself, a stuffy room, a computer that keeps lagging, or even a test booklet with missing pages. Okay, so if the goal is to fight error and measure consistency, how do we actually do that? Well, researchers have a toolkit with 4 main approaches. You can think of them as 4 different flavors of reliability, each designed to sniff out a different kind of inconsistency. So here are the 4 main tools in the kit. First, you've got test-retest reliability. This is our Monday-Tuesday scenario, exactly. You give the same test twice to see if it's stable over time. Then there's inter-rater reliability. This is absolutely crucial when humans are doing the scoring, like for an essay or an Olympic dive. You check if 2 different judges give similar scores. Third, parallel forms. This is for when you have, say, Form A and Form B of an exam. You want to make sure both versions are equally difficult. And finally, internal consistency. This one looks inside a single test to make sure all the questions are basically playing for the same team and measuring the same thing. But here's the cool part. This idea of consistency isn't just some vague concept. We can actually boil it down to a single hard number. And we do that using a statistic called a correlation coefficient. For reliability, this number goes from 0 to 1. Think of it like a trust meter. A 1 means perfect reliability. Your observed score is your true score with 0 error. A 0 means a score is pure random garbage. So the closer that number gets to 1, the more consistent and the more trustworthy that test score really is. So what do these numbers look like in the real world? Well, at the very top, you might see a score like 0.90 or even higher. This is the gold standard. This is the kind of rock-solid consistency you demand from a high-stakes test, like a medical board exam or the SAT. Now, not every test needs to be that perfect. For a lot of research, a score around 0.75 is considered pretty solid. In fact, many scientists use 0.70 as the bare minimum cutoff for a test to even be considered useful. But what if you see a number like 0.40? Oof, that's a huge red flag. A score like this means the test is mostly just random noise. Any decision you make based on a test this unreliable is basically a coin flip. Look, I know this can all seem a little abstract and technical, but the stakes here are incredibly high. Understanding this stuff isn't just for academics. It has huge real-world consequences for everything from your grades to a medical diagnosis. And here is the single most important thing to remember. Reliability is the absolute foundation of a good test. If a test isn't reliable, if it gives you wildly different answers every time, then it can't possibly measure what it says it's measuring. An unreliable score isn't just a bad score. It's a meaningless number. You just can't trust it. But the good news is we can actually fight back against all that error. Test makers have a bunch of tricks up their sleeve to improve reliability. Simple stuff makes a huge difference, like just adding more questions, because randomness tends to cancel itself out with more data. Or writing crystal clear instructions so everyone starts on the same page. And, of course, getting rid of confusing or ambiguous questions. It's all about controlling the noise to get a cleaner signal. So the next time you see a score, any score, I want you to think about its secret life. That silly online personality quiz you just took, how much of that result was the real you and how much was just, the error of the moment? Understanding that difference is the first step to becoming a smarter consumer of data in a world that is absolutely swimming in it.